Today we're going to talk about 2003 AMC 10B Problem 24. The first four terms of an arithmetic sequence are x plus y, x minus y, xy, and x over y in that order. So what is the fifth term? And we have 5 options, A, B, C, D, E. So no matter how you choose to do this problem, you will realize that the key point here is to write either x as y or y as x. But before that, first let's use the part where we know the 4 terms are an arithmetic sequence. So an arithmetic sequence has a common difference d. And the common difference is equal to the first term minus the second term. The second term minus the first term. The second term is x minus y, and the first term is x plus y. So if we subtract the first term from the second term, we get that d is equal to negative 2i. So the common difference between all of these terms are negative 2i. Therefore we know that x minus y minus 2y equals xy, because this is the second term, a2, this is the third term, a3. And we know that a2 plus d equals a3, so basically x minus y minus 2y equals xy. So we have an equation here. X minus 3y equals xy, and we're going to try to solve for y. So we try to solve for y and represent y in terms of x. Then what we can do is we move all the terms of y onto one side. We move terms of only x onto the other. And then we factor out the y, and we divide both sides by negative 3 minus x, so we get negative x over negative 3 minus x. So this is actually essentially just x over x plus 3. So we now have this equation called y equals x over x plus 3. So now we should use this equation to perform some other calculations. So we still haven't looked at this term yet in the relationship between these two terms and also these two terms. So we know that xy minus 2y is x over y, and we already know that y is x over x plus 3. So we have x times x over x plus 3 minus 2 times x over x plus 3 is equal to x over x plus 3. So we're going to evaluate this term here, this whole equation here. We have x squared over x plus 3 minus 2x over x plus 3. And we also have x over x plus 3, which is just x plus 3 itself. So now we have evaluated the equation. If we choose to multiply both sides by x plus 3, so we don't have any denominators, we have x squared minus 2x is x plus 3 squared, which is just x squared plus 6x plus 9. So the x squares on both sides can cancel out, and we have 8x plus 9 equals 0. Therefore we have 8x is negative 9, and x is negative 9 over 8. So we now have x is negative 9 over 8. So therefore we can also figure out what y is. So y is just x over x plus 3, which is negative 9 over 8 over 24 over 8 minus 9 over 8. So 3 can be written as 24 over 8. And we have negative 9 over 8 over 15 over 8. So the 8's cancel out, and we have negative 9 over 15, which we can cancel out a factor of 3 from these two numbers. So we have negative 3 over 5. So y is just negative 3 over 5. So now we have x and y. x is negative 9 over 8 and y is negative 3 over 5. We want the fifth term of this sequence, and the fourth term is x over y. So all we have to do is add x over y to the common difference and we'll get the fifth term. So we have x over y. If we add it to the common difference, which is 2y, then we'll get the fifth term. So we have to just evaluate this expression here. So basically we have negative 9 over 8 over negative 3 over 5 minus 2 times negative 3 over 5. Therefore we have 9 over 8 times 5 over 3. The negative signs cancel out, and we can factor out a 3 from here. And then we also have plus 6 over 5 because the negative signs cancel out once again. So basically our whole expression is 15 over 8 plus 6 over 5. We can make this have a common denominator of 40. So if we multiply 15 by 5, we have 75. If we multiply 6 by 8, we have 48. And the common denominator is 40. So this just gives us 123 over 40. And if we look at the answer choices, we do find 123 over 40. That's option E. So this is our solution to 2003 AMC 10B problem 24. The main takeaway in this problem is that you have to use the fact that the terms are an arithmetic sequence to write equations, and you also have to substitute either x into y or y into x. So thank you and bye.